Hello student, in our last lecture we studied about group number 15 elements, and in the group number 15 element we studied about the reactivities of the group number 15 elements with hydrogen, oxygen, halogen and reactivity with metals. Now, in this lecture, we studied about the different type of the compound that is formed with the help of group number 15 elements. So first we discuss about the dinitrogen. Dinitrogen was discovered by the scientist named Daniel Rutherford, and we know that the dinitrogen is obtained in a diatomic form. So nitrogen that is going to react with the other nitrogen, and both are combined with each other with the help of triple bond. Dinitrogen is obtained in gaseous form. So in this compound preparation, here we have to study majorly three factors. First point is the preparation, second is the properties, and the third important point is uses. First we discuss about the preparation of dinitrogen. Dinitrogen is obtained by the liquefactions and the fractional distillations of air, because we know that in air 78% nitrogen is present. Now student, this dinitrogen is also prepared in laboratory by thermal decompositions. So ammonium dichromate on its heating gives dinitrogen. During this reaction Cr2O3, chromium trioxide is obtained as byproduct. Dinitrogen is also prepared from barium azide and from sodium azide also. So barium azide on its thermal decomposition gives barium plus nitrogen. Properties of dinitrogen. Dinitrogen is colorless, odorless, tasteless and non-toxic gas. It having two isotopes, N14 and N15. What is the meaning of isotope? Isotope it means the species which having the same atomic number. We know that the atomic number of the nitrogen is 7, but the different atomic mass is called isotope. Dinitrogen is lighter than air. It is less soluble in water. It is inert at the room temperature. But as the temperature increases, the dinitrogen can react with the metal as well as non-metal. So at a higher temperature, the dinitrogen can react with the lithium and magnesium. Lithium on its reactions with the nitrogen form lithium nitride. Similarly, the magnesium on its reactions with the nitrogen form the magnesium nitride. Reaction with non-metal. So dinitrogen can also react with the non-metal like hydrogen and oxygen in order to form ammonia and nitric oxide respectively. First important reaction is Haber's process. Haber's process, it is also known as the preparations of ammonia. With the help of this process, we can prepare ammonia in laboratory as well as in industry also. Nitrogen on its reactions with the hydrogen at 773 Kelvin temperature at 200 atmosphere pressure in the presence of iron oxide catalyst gives 2 moles of ammonia. Similarly, nitrogen on its reactions with the oxygen gives nitric oxide. Ammonia. Ammonia. First preparation of the ammonia. First is laboratory preparation. In laboratory preparation is also known as a small scale preparations. In laboratory, how can we prepare the ammonia? So the ammonia is obtained with the help of ammonium chloride plus NaOH. NaOH is known as caustic soda, or it is also known as sodium hydroxide. So this sodium hydroxide on its reactions with the NH4Cl gives what? Gives Na plus Cl, gives NaCl plus H2O is released during the reaction, and rest is ammonia is obtained at the end of reaction. Industrial preparation of ammonia, or it is also known as a large scale preparation. Here we can prepare the ammonia in industry with the help of Haber's process, as we discuss further. Nitrogen on its reactions with the hydrogen at the 773 Kelvin temperature, 200 atmosphere pressure in the presence of iron oxide. This iron oxide is act as catalyst during the reaction. In presence of molybdenum. What is a molybdenum? Why we add the molybdenum? So molybdenum is catalytic promoter which increase the rate of catalytic reaction. Again, this molybdenum which increase the rate of catalytic reaction. Okay, so when we add this, so this nitrogen on its reactions with the hydrogen gives 2 moles of ammonia. During these reactions, energy is released, heat is evolved. That's why this type of the reaction is called exothermic reaction. Is called exothermic reaction. This type of the condition, this reaction condition, it means 773 Kelvin temperature, 200 atmosphere pressure, presence of iron oxide as catalyst and molybdenum is called optimum condition. Is called optimum condition according to Le Satirial principle. According to Le Satirial principle, it means we can get the maximum product with the help of this condition. With the help of this condition. Now the properties of ammonia. Student, we know that the ammonia is colorless gas with the pungent smell. And the structure of the ammonia. In the structures of the ammonia between the nitrogen and hydrogen, single bond is present, so it having a sp3 hybridization. When any species shows sp3 hybridization, it indicate the trigonal pyramidal shape. So it having a trigonal pyramidal shape. Three bond pair are present. 1, 2, 3, and one lone pair of electron is also present. In structure of ammonia, the bond angle is 107.8 degree. Now the ammonia is soluble. Properties: ammonia is soluble in water, and when we try to dissolve the ammonia in water, it releases the OH minus ion. And we know that the substance which donate the OH minus ion indicate which type of the nature? Basic nature. So we can say that the aqueous solutions of the ammonia is basic in nature. Second point, ammonia on its reactions with the acid form ammonium salt. Like ammonia on its reactions with the acid like HCl and H2SO4 form the salt, ammonium salt, like NH4Cl is called ammonium chloride and NH4 twice SO4 is called ammonium sulfate. Next point, the ammonia is act as Lewis base. Which is called Lewis base? Simple. The species which donate electron pair is called Lewis base. So, see student, here the ammonia which having a lone pair of electron on its reactions with the metal like copper, that gives the complex compound like CuNH3,4. copper, which having a blue color on its reactions with the ammonia, gives the deep blue color solution. The structure of this complex compound is like this: Cu NH3 4 plus 2 is charge. Now the lone pair of electron present on the nitrogen in ammonia, that is donated by the nitrogen towards copper. As this ammonia donate the lone pair of electron to copper, it is act as Lewis base. So we can say that this ammonia, due to the presence of lone pair of electron and possess the tendency to donate the electron pair, is act as Lewis base. Similarly, Ag plus on its reactions with ammonia gives AgNH3 twice, which is colorless. Students, now the nitrogen on its reactions with the oxygen forms the various types of oxides of nitrogen like N2O, NO, N2O3, NO2, N2O4 and N2O5. This N2O is called nitrogen 1 oxide, NO nitrogen 2 oxide, N2O3 nitrogen 3 oxide, NO2 nitrogen 4 oxide, N2O4 nitrogen 4 oxide and N2O5 nitrogen 5 oxide. Now physical appearance and the chemical nature of these oxides of nitrogen. This N2O and NO are colorless gas and neutral in nature, while N2O3 is blue color solid and acidic in nature. NO2 nitrogen dioxide is brown color solid and acidic in nature, while this N2O4 and N2O5 are colorless solid and acidic in nature. So first two and last two are colorless. First two compounds are neutral in nature and the last two compounds are acidic in nature. Now the preparation. Preparation is important. Now the preparation for the N2O. N2O is called nitrous oxide, is obtained by the decompositions of ammonium nitrate. This ammonium nitrate on its decomposition gives N2O. Similarly, NO, nitric oxide, is obtained with the help of ammonia on its oxidation reaction gives NO. This reaction is called first step of Oswald process. We use the Oswald process for the productions of nitric acid, while the N2O3 is obtained with the help of NO and N2O4. This reaction takes place at the lower temperature, while the NO2 is obtained by the decompositions of lead nitrate. This lead nitrate on its heating gives lead oxide plus NO2, while the nitrogen dinitrogen tetroxide is obtained. Here the dinitrogen tetroxide is obtained by the 2 moles of NO2. 2 moles of NO2 on its reaction gives dinitrogen tetroxide. On its reaction gives dinitrogen tetroxide, while the last N2O5 is obtained by the reactions of nitric acid with P4O10. Remember students, P4O10 is dehydrating agent. What is the meaning of dehydrating agent? Which release the H2O during the reaction is called dehydrating agent. So nitric acid on its reactions with the P4O10 gives HPO3 plus N2O5. HPO3 is called metaphosphoric acid. Now the preparation properties of nitric acid. Nitric acid. Nitrogen forms the various types of the oxo acids. Oxo acid, it means what? First of all, oxo acid, it means the compound which possesses OH ion, even though which indicate the acidic property is called oxo acid, so the nitrogen forms various oxo acids like HNO2, HNO3 and H2N2O2 is called nitrous acid, nitric acid and hyponitrous acids respectively. Preparation of HNO3. First preparation is a small scale preparation, or it is also known as a laboratory preparation. So in laboratory we can prepare HNO3 with the help of sodium nitrate and H2SO4. So sodium nitrate on its reactions with the H2SO4 gives sodium hydrogen sulfate and HNO3 is released during the reaction. Second preparation of the nitric acid is industrial preparation, or it is also known as large scale preparation. We can prepare the nitric acid with the help of Oswald's process. So the ammonia on its reaction with the oxygen in the presence of platinum or rhodium catalyst at 500 Kelvin temperature and 9 bar pressure gives nitric oxide and H2O is released during the reaction. This nitric oxide in second step on its oxidation reaction gives nitrogen dioxide. This nitrogen dioxide on its reactions with the H2O gives HNO3. The HNO3 is obtained during the reaction having a concentration 68% by mass. So the concentration of this HNO3 can be increased by additions of H2SO4. H2SO4 is also dehydrating agent. So by additions of the H2SO4 students हम लोग HNO3 का concentrations जो है वो increase कर सकते हैं from 68% to 98%. Okay. Second important thing, NO, nitric oxide, which is obtained during the reaction is also used in second step. So फिर से ये NO ऑक्सीडेशन रिएक्शन करेगा, नाइट्रोजन डाइऑक्साइड फॉर्म कर सकता है और ये रिएक्शन फिर से सेकेंड टू थर्ड स्टेप में कैरी फॉरवर्ड होगी. प्रॉपर्टीज ऑफ नाइट्रिक एसिड. Nitric acid is colorless liquid having a specific gravity 1.504. तो specific gravity, otherwise it is also known as relative density. So the relative density of nitric acid is 1.504. Nitric acid. Now nitric acid in its gaseous state having a planar structure. Planar structure, it means this bond which is remain in the same plane. हर कोई जो बॉन्ड है between the O and H, between the O and N, between the N and O, हर कोई एक ही प्लेन में होगा. So it's called planar structure. Acidic nature of nitric acid. So the nitric acid on its reactions with the H2O gives hydronium ion which is responsible for the acidic nature of nitric acid. Next, nitric acid on its reaction with metal. See, this reaction with the metal is very important. Many times many questions ask from this point, like nitric acid on its reactions with the metal like copper and zinc. If we use the concentrated nitric acid, then it always gives nitrogen dioxide. Remember, this is most important. When we use the concentrated nitric acid, then it always gives the nitrogen dioxide. So copper or zinc on its reactions with the nitric acid gives the copper or zinc nitrate and NO2 is released during the reaction. Instead of the concentrated nitric acid, if we use the dilute nitric acid, then that gives NO or N2. It means nitric oxide or nitrous oxide. So copper on its reactions with 8 moles of HNO3 gives copper nitrate. NO, nitric oxide plus H2 is released during the reaction. Zn on its reactions with the dilute HNO3 gives zinc nitrate plus N2 is released during the reaction. Once again, if we use concentrated HNO3, it always gives NO2. Instead of this concentrated HNO3, if we use dilute HNO3, it gives NO and N2O respectively. Now the reaction with the non-metal. This HNO3 can also react with the non-metals like phosphorus, sulfur, iodine and carbon. So HNO3 on its reactions with the phosphorus. Now see students, here we use concentrated HNO3 which always gives NO2. So phosphorus on its reactions with the HNO3 gives phosphoric acid. NO2 is released during the reaction. HNO3 on its reactions with the sulfur gives sulfuric acid plus NO2 is released during the reaction. In all reactions, H2O is released, which clearly indicate that HNO3 is good dehydrating agent. Now Brown ring test and the test for the detections of nitrate ion. In laboratory we can detect the nitrate ion with the help of this test. So in this test, nitrate ion containing solution, first we have to add the freshly prepared iron sulfate in nitrate ion containing solution. So in this test tube, when we add the freshly prepared iron sulfate solution in nitrate ion containing solution, and after that when we add the H2SO4, so when we add the H2SO4, so here we have to add the H2SO4 dropwise. So when we add the H2SO4 dropwise, then when this H2SO4 touch the surface of this solution at this interface, when this H2SO4 touch the surface of this solution at this interface, brown color ring is formed. At this interface, brown color ring is formed, and the presence of brown ring clearly indicate the nitrate ion. Okay, so chemical reactions for the detections of the nitrate ion on its reactions with the freshly prepared iron sulfate in the presence of sulfuric acid gives this NO3 minus, experience which type of the reaction? Reduction reaction, while this Fe plus 2 experience oxidation reaction. After that, this Fe plus 2 which is present in its aqueous form on its reactions with the nitric oxide which is obtained from the first step. So this nitric oxide on its reactions with the aqueous solutions of the iron sulfate gives FeH2O5NO, which indicate the presence of brown ring, and this brown ring which indicate the presence of nitrate ion in solution. Thank you for watching, students.